Hey everyone, it's Ken. Today we're going to talk about L'Hopital's rule for infinite limits. And what I mean by that is L'Hopital's rule just in the special case where the x values are not approaching a fixed number, but they're actually approaching a plus infinity or negative infinity. And so it turns out the usual L'Hopital's rule that we know and love still works. There's no problem. It's just that in case, say, we're letting x go to infinity, we're taking an infinite limit. In other words, thinking about a horizontal asymptote. If we're looking at limit of f over g, and if f over g gives us an indeterminate form, then it'll be true that this is just equal to the limit. So x goes to infinity of f prime of x over g prime of x. And the only conditions that you need here are, well, you're going to need, let's ask as usual for f and g both to be differentiable, for those derivatives to be continuous. And we'll ask that the denominator here, the derivative should be non-zero. But if those conditions are met, and if you have an indeterminate form, then L'Hopital's rule works. So I want to do a quick example illustrating this. So let's take, for instance, the limit as x goes to infinity, of natural log of x over x. And so what we're trying to investigate here is something that you'll hear people call the asymptotic behavior. In other words, the behavior as the x values in the domain go to infinity. So you know that natural log of x goes to infinity as x goes to infinity. You know that x goes to infinity, of course, as x goes to infinity. And then you're asking, but how fast, relative to each other? So if natural log of x over x goes to infinity twice as fast as x, then you're going to expect that this limit will be equal to 2, for example. So knowing that I have an indeterminate form, infinity over infinity, I can use L'Hopital's rule. So let's just take the derivative of natural log of x, that's 1 over x. Derivative of x is equal to 1. And now I can just look at the limit as x goes to infinity of 1 over x. And so 1 over x tends towards 0 as x tends towards infinity. And so that's L'Hopital's rule. If I just had this expression, there's no way I could have, just from looking at it, intuited that the limit would be 0, but just applying L'Hopital's rule, quickly taking those derivatives, I quickly and cleanly get an answer. So this is going to be telling us that x is going to infinity much faster than natural log of x, if you think about it, because x getting large pushes that fraction down to 0. Natural log of x getting large pushes the fraction up, and x is winning. It's going to infinity a lot faster, causing that limit to be equal to 0.